solve 1 plus y square plus x minus exponential power of tan inverse y into dy, which is equal to 0. We have to note that the problem is not directly given as of the form linear differential equation. Instead, we have to reduce this equation to one of the forms of linear differential equation. For that, here take this 1 plus y square to the right hand side, we get as x minus exponential power of tan inverse y into dy by dx, which is equal to minus of 1 plus y square. Here the linear differential equation of the form dy by dx plus px into y, which is equal to qx, or we have to reduce this to the form dx by dy plus py into x, which is equal to qy. Here if we take this x minus exponential power of tan inverse y to the right hand side, that goes to the denominator, and if we simplify further, the equation becomes complicated. So to make the simplification easy, take this dy by dx to the right hand side, that becomes minus 1 plus y square into, here if we take this dy by dx to the right hand side, if dx goes to the numerator and dy goes to the denominator, hence becomes dx by dy, which is equal to here x minus exponential power of tan inverse y as it is. Now if we take this value to the right hand side, that becomes dx by dy, which is equal to, here this goes to the right hand side, here negative value also goes to the right hand side, that becomes here minus x minus into minus plus exponential power of tan inverse y. Take this value first, hence we get exponential power of tan inverse y minus x divided by 1 plus y square. Now if we split this value, we get as exponential power of tan inverse y divided by 1 plus y square minus x divided by 1 plus y square. You have to observe carefully. This is our dx by dy value. Here if we take this value to the right hand side, that becomes 1 plus y square divided by x minus exponential power of tan inverse y. Hence the simplification becomes complicated. Therefore, I take dy by dx to the right hand side, hence we get dx by dy into minus 1 plus y square. If we take this value to the right hand side, if we multiply minus inside the bracket, we get as exponential power tan inverse y minus x divided by 1 plus y square. If we split this value, we get this, that is exponential power tan inverse y divided by 1 plus y square minus x by 1 plus y square. This is our dx by dy. Now take this value to the left hand side, we get as dx by dy. If we take this value to the left hand side, that becomes minus value becomes positive sign of 1 by 1 plus y square into x, which is equal to here exponential power tan inverse y divided by 1 plus y square in the right hand side itself. Now we can conclude that this differential equation is of the form dx by dy plus p of y into x, which is equal to q of 1. So this is a differential equation of the form dx by dy plus py into x, which is equal to qy. Now take the p and q value, where p is nothing but 1 by 1 plus y square, q is nothing but exponential power tan inverse y divided by 1 plus y square. In previous two problems, the differential equation of the form dy by dx plus px into y, which is equal to q of x. But this problem is of the form dx by dy plus py into x, which is equal to qy. Now in the next step, find the integrating factor. We know that integrating factor for the value p. Here p is of the form 1 by 1 plus y square. Therefore exponential power integral of p into dy. This is an integrating factor. Substitute p value and evaluate the integration, we get as exponential power of integral of p value is 1 by 1 plus y square into dy. We know that 1 plus 1 by y square into dy, this is integration value is tan inverse y. Therefore this value becomes exponential power of this value is integral of 1 by 1 plus y square is tan inverse y. This is an integrating factor. Once you obtain the integrating factor, the solution for a given differential equation is of the form x into exponential power of integral of p dy, which is equal to integral of q into exponential power of integral of p dy into dy plus c. Substitute integrating factor value and q value over here and simplify, we get as x into this value is exponential power tan inverse y, which is equal to integral of, here q value is exponential power tan inverse y divided by 1 plus y square into this value is exponential power tan inverse y into dy plus c. Now we have to simplify the integration. Here also e power tan inverse y, here also e power tan inverse y. This becomes e power 2 into tan inverse y. In the denominator we have 1 plus y square. We know that differentiation of tan inverse y is 1 by 1 plus y square. Similarly, integration of 1 by 1 plus y square is tan inverse y. So, to simplify the integration, in next step we have to put in the place of tan inverse y as t. Therefore, differentiating this term with respect to y, we get as differentiation of tan inverse y is 1 by 1 plus y square into, again differentiation of y is into dy, which is equal to, here differentiation of t is dt. Therefore, substituting this value over here, we get as, here in the place of 1 by 1 plus y square into dy, we have to substitute as dt, and in the place of tan inverse y as t, we get as here x into e power t, which is equal to integral of, here this value is e power t into, here this value is also in e power t into, here 1 by 1 plus y square into dy is dt plus c. Now e power t into e power t is e power 2t. Therefore, we know that integration of e power 2t is e power 2t divided by 2 plus c. Substitute t value as tan inverse y. Again we get as x into e power tan inverse y, which is equal to e power of 2 into, in the place of t as tan inverse y divided by 2 plus c. This completes the problem.